Hi, welcome to Wipro Intelligence, a fireside chat hosted here at Wipro booth in Las Vegas at CES. I'm Suruchi Gupta, General Manager and Global Head for Partnerships and Ecosystem at Wipro Engineering. Our theme for today is Accelerating SDLC, Digital Twins powered by Siemens with PAVE360. We'll explore how chip-to-card digital twins compress development cycles, improve quality, and de-risk launches, connecting EDA, embedded software, and vehicle systems engineering from cloud scale simulation. Joining me today on my panel are David Fritz, Senior Vice President, Siemens PAVE360, Debasish Chanda, Chief Architect and Practice Head of Automotive, Wipro Engineering, Vice President and Global Head for Automotive Engineering at Wipro. We will start today's conversation with SDLC pain points and the role of virtual validation, understanding the bottlenecks today, requirements churn, late hardware software integration, validation coverage, and compliances. How do they change the game? How do digital twins change the game? I'd like to ask David Fritz, from Siemens PAVE360 perspective, what distinguishes a true chip-to-card digital twin from the siloed simulation, and how does that reduce late-stage integration risk?
Well, thank you for inviting me today. It's a pleasure to be here at Wipro, and I appreciate the opportunity to represent Siemens and PAVE360. PAVE360, as we just recently announced, is a representative blueprint of a full automotive development environment that fits nicely within an SDV flow. PAVE360 addresses simulation all the way down from the chip level to the system level, and making sure that at each iteration through the CI/CD process flow that you're meeting the requirements that are required. What that does is that helps you shorten time to market. It helps you resolve integration storm issues very early on in the process and give you a better quality program at the end, both pre-SOP and post-SOP.
Thank you. Dave, picking up from where David was talking about, architecturally, what are the best practices and patterns to connect PAVE 360 environments with the embedded CI/CD, test orchestration, and traceability?
Yeah. So, in Wipro, we have developed test Genie solution where we are connecting the requirement. From there, we have used the AI to generate the solutions from the requirement. The test cases are generated, and the test cases are done in a behavior driven way so that we can segregate the what and how part, and then we are connecting with the Siemens platform where the multiple issues can get interconnected. That is the one advantage what we get from the Siemens, where we have a backplane, and so that we can connect the multiple issues and can do a full-fledged system level validation. Only thing is there are few issues like thermal and those things we still need to have the hardware, but otherwise the most of the functionality can be tested, and as David explained, it can actually shorten the life cycle a lot, because most of the software can be verified even before the hardware is available. Yeah.
From your perspective, Dr. Suru, where do you see the tier ones and the OEMs most benefit from the virtual validation?
If you look at today cost for an entire SDLC, so even in the early days, majority of the cost of the development, even there is a reuse of the software, comes from validation effort. Even if I take a decent vehicle program, so number of full cycle testing they need to undergo to ensure the launch quality, that takes a good amount of effort and time and the cost. Now, if we really create an environment which will bring in the entire environment when we're developing the software, and even the development stage, we can get some integration testing done, which otherwise actually it would be revealed towards the end of the cycle. So if we get any defect towards the end of the cycle, that costs more, because you have to have the fix of it again, running the entire test cycles to make it completely defect free. So it actually exponentially increases the cost. So this particular tool which you have developed with Siemens that gives an environment, virtual environment, which will help to really test in the early phase of the development life cycle, and we call it in the development life cycle called lab shift. Not only reduces the time to develop and also reduces the cost and effort, and also ensure the quality. So in all three dimensions, one is dependent on other, and that's how it is becoming exponential savings if we deploy this any kind of software, embedded software development where hardware dependency is high. So that's how I think this particular platform is very relevant.
Thank you. Thank you, Dr. Saru. Now let's go deeper into how PAVE360 supports hardware, software, verification, virtual ECUs, and system-level validation before the physical prototype exists. David, how does PAVE360 enable pre-silicon software bringing up on virtual ECU stacks, and how do teams synchronize with real hardware later?
One of the key aspects of being software defined is early on in the development cycle having both the hardware and the software pliable, because the software can impact the hardware and the hardware can impact the software. So having the ability to have both flexible as you refine the architecture for both the hardware and software gives you a much better opportunity to find these issues very early in the process. That requires special technology, special computation capability in order to accomplish that. So about a year and a half ago, Siemens introduced a brand new technology called architecture native acceleration that allows the software to run in real time on top of virtualized hardware. That means that if there is a problem in that process, then you can either change the hardware or change the software to match the hardware. The end result means that you've got simulation happening in special compute environments designed specifically for that hardware software simulation, and you resolve lots of issues very early in the process in that way.
Debasish, how do you couple electronics level models with system level functional models to ensure consistent timing and resource constraints?
Yeah. So that's a tricky question. I think the way we are doing it is we are creating a functional mock-up unit which matches the exact ECUs which we are wanted to substitute. But otherwise, we are taking the binary of the ECUs, and as David explained, the new architecture of native acceleration can help us to meet the performance requirement, what is expected at the hardware level. I think we have tested and we have seen the performance with this native acceleration is quite matching with the industry expectation. So that's the good news for us. So I think with this we are able to meet the resource constraint, and also we will be having the periodic evaluation of the memory as well as the MIPS requirement to see that whether we are going in the right direction.
Thank you. Dr. Surup, I'm going to just shift a little and talk about the model-based system engineering and continuous verification, and I have a question directed to you on that. What governance model enforces safety and compliance gates while still enabling the rapid iteration in the twin environment?
So this is a very tricky question, and multiple dimensions are there. One is a model-based system engineering, so which you have spoken about. It actually creates the digital thread. It helps to create the digital thread. It's not only the software development; it is also the hardware as well as mechanical vehicle per se. So if you really take any activities which actually help to really develop the vehicle, manufacture the vehicle, as well as operate the vehicle. So if you look at this whole entire life cycle of the vehicle, MBSE, which is model-based system engineering, will help you to really create a digital thread. That means that when you are doing the design, you have got a complete cognizance of the fact that how it will be operating. And also if you feel that when you are operating the vehicle, then if some feedback needs to go into the design, it can easily take it. So this creates the loop. That's how the digital thread helps not only building the vehicle, but also developing and manufacturing the vehicle. Now, where this virtualization and digital simulation comes in every step, when we perform certain activities to ensure the safety of the vehicle. So then you need the simulated environment, right? So that means if your vehicle is there, otherwise your simulated vehicle is there. So whatever the safety critical activity to ensure safety compliance and as well as safety of the vehicle, you can really carry out in the virtual form before even the vehicle is in place. So that means you don't have to wait that the vehicle is completely manufactured, proto is available for testing it, but you can still carry out your testing there. So if I try to really build this entire cycle and protos, then virtualization is the building block for building such simulations. So virtualizations may be done in the subsystem, it could be done in the integrated subsystems, which is nothing but the vehicle today. And then if we extend it to the manufacturing and deployment stage, then it gives that entire digital twin. So that's why virtualization, simulation, digital twin, these are the few areas which actually everybody is exploring every phase of building, manufacturing, and operating them.
In continuation, I'll get your perspective, Debasish, and add some comments on how would you implement the automated regression suites that are running nightly against the twin instances, and how do you triage the failures efficiently?
The way we were doing it, we are having our own product called TestGenie, and in TestGenie we have the suite for the entire test suite, and also based on the changes what we see on every commit, we do a regression test selection, and from the regression test suite we can perform the regression. And one important point I wanted to highlight here is, here we can do some of the safety injection testing, which is otherwise very difficult to do it in hardware. So it just not gives only the performance benefit, but also for safety testing it is very, very useful, because hardware may become unusable with some of the testing, and that OEM can't afford. But here, because it is a virtual environment, all you need to do is just restart.
Let's talk about integration and ecosystem now. To scale, we need robust integration, EDA tooling, cloud simulation, hardware in the loop, secure OTA, and cyber resilience. I'm going to ask David his perspective on the key integration patterns between PAVE360 and the popular EDA tools, and how do you keep model fidelity across the tool boundaries?
So, number one, at the top, the belief and understanding that no one company, as large as Siemens is, could actually solve all of the problems. So at Siemens, we take an open interface approach to the problem, where we can interface with any number of tools using standardized interfaces. What that allows us to do is play a role in the whole SDV methodology and flow without requiring our customers to use very specific and proprietary tools, which is a big benefit. So that means that any existing flow, we can fit into that flow. And without the high fidelity digital twin in the middle of the flow, then as we've heard earlier, it's virtually impossible to know where you are in the process of verifying that you're meeting the requirements at a high level or a low level, all the way from the system perspective down into the silicon perspective. So we have to be able to run realistic workloads, working on realistic stimuli. And then the question is, when that realistic stimuli comes in, how do you handle spurious problems? Which is the real subtle problem and a difficulty in building these complex systems. And the answer to that is, not only does the flow have to be deterministic, but the digital twin itself must be deterministic and be at the right level of fidelity for the level of testing and requirements that you're trying to prove that you're meeting.
Thank you. Dr. Suruchi, so if I piggyback off of that, how do you validate resilience, the fault injection, chaos experiments, and the failure mode analysis?
So it's again a very standard process to do it, even if you do it manually, and even if you do it through automations, right, or to the physical setup or the virtual setup. As Debasish mentioned, that everything has got a cost associated with it. So if you do the fault injections in the systems, then you may have to create a lot of protos which are costly, and also you may have to create in time. So when you have to do it, the fault injection set so that the safety has been complex. So here actually, if you do the virtual, you have got all the flexibility that when you are doing it, and on what aspect you are doing it. Are you really getting the entire integrated system, or is there partial subsystems? All these permutation and combinations of the scenarios you can build so easily. So that gives you the pathway that you can continuously build your safety throughout the development life cycle. You don't have to wait that entire system is available to do that. That's what Debasish also told. That's what the beauty of the modeling, visualizations, and simulations, whatever you do.
Thank you. Now it's very important to talk about business case and ROI, the time to market, cost, and quality. How digital twins reduce rework, accelerate, and lift software quality with practical metrics. David? Examples where PAVE360 materially reduced late-stage issues, and what were the before and after metrics and lessons learned is my question to you.
I think the best way to answer that is an experience that I had not long ago, just north of Munich with an OEM facility. And they took me for a tour, and they showed me all of their hill rigs. Each hill rig could be $3 to $4 million. And the building was so big, it was foggy at the other end. It was so long, there had so many hill rigs. And I asked, how do you use these? And what they said was, we hire these contractors to come in 24 hours a day, 7 days a week. They have a little checklist, and it says, push button A, does light B come on? Yes, it does. So they went through this very complicated process, hiring all these people, and they may have half a dozen or a dozen hill rigs for each model year. And that's why they had so many. Now imagine with the methodology that we're talking about, they simply go home on a Friday evening and run a script and come back Monday morning, and it tells you what passed and what failed. It's hard to quantify the savings of that magnitude. And then we have more esoteric aspects. We're finding these problems early. We can adjust our architecture before the hardware actually exists, as we mentioned earlier. So the benefits go on and on. It can be very hard to quantify, other than the fact that they are orders of magnitude higher than most people expect.
Thank you. Debashish, how do you see Wipro, Siemens, and OEMs structure partnerships to share risk and accelerate value, templates, accelerators, and outcome-based engagements?
Yeah, we are seeing some early success where with the OEM and as well as with the tier one, we are able to stitch the partnership. The partnership would be like this. The customer will take the Siemens PAVE360 for their virtualization of their ECUs, and some of the associated ECUs need to be simulated using the functional mockup unit, and then they take our TestJD solution, which can help us to do the test automation. And we are seeing that some of the test automation, what we did, it works with the customer. They are coming back to us. Can you leave the device under test, and can you try to do it in the virtual environment? Because it does not only help the tester, but also help the developer. Because developer needs to see their feature working in the virtual environment, and that is the big advantage it can bring really.
Thank you to all the panelists for joining us at Wipro Intelligence here and for a fireside chat. If you'd like to see how Wipro and Siemens PAVE360 accelerate SDLC from pre-silicon validation to vehicle-level testing, please visit our demo zones or meet our experts right after the session. Thank you.